Alright, let's do some practice calculations to make sure we understand both parts A and part B of our titration lab, so we know how we were able to standardize or figure out the concentration of the sodium hydroxide first in part A, and then how we were able to use that concentration of the base to figure out the concentration of our acid in part B, which was vinegar. Okay, so our overall goal is to figure out the molarity of vinegar. First, we have to figure out the concentration of the base. So let's go through part A first. So in part A, we had a burette, which is this piece of glassware, filled with sodium hydroxide. Okay, that was NaOH. In the burette, you filled it to that 0 line marker way at the top. Now, it might not have been exactly 0. Maybe you read it and it turned out to be 0.08 milliliters of sodium hydroxide. Okay, and then in the flask down here, we measured out ideally 0.5 grams, so maybe it was 0.501 grams of oxalic acid. That was the powder that was set up by each balance, and then you balanced out hopefully about 0.5 grams, put it in that flask, and then filled it to about maybe 50 milliliters of deionized water to make an acid solution. So we know that there is exactly 0.501 grams of oxalic acid in that beaker, or sorry, in that flask. So we want to figure out how much sodium hydroxide does it take to neutralize that oxalic acid. So let's take a break for just a second there. We got to talk about that neutralization reaction. What happens is we are mixing the acid and the base together, okay? Those are our two reactants, whatever is in this flask right here, the oxalic acid, and whatever sodium hydroxide is in the burette. So basically we are adding sodium hydroxide, which is NaOH, to oxalic acid. The formula for that is H2C2O4. When you mix those together, you're going to have a neutralization reaction occur. So the cation in sodium hydroxide is sodium. The cation in oxalic acid is hydrogen. The anion in sodium hydroxide is hydroxide. The anion in oxalic acid is oxalate. This is simply a double replacement reaction. There's nothing new that we ever learned here. It's the same as every double replacement reaction. So if sodium is the cation here, it will recombine with the anion in the other one. So the result is Na2C2O4, because sodium is a +1 and oxalate is a -2. And then I will also get the cation from the acid, which is H, with the anion from the base, which is OH. H is a +1, OH, hydroxide, is a -1. That's water. Okay? So I'm going to get rid of my little underlines here. So now it is important for us to balance this. What I want to do now is make sure that I have the right number of elements on both sides. I need a 2 here. I need a 2 here. Alright, so the point of balancing it is now I know that there's a 1 here and there's a 1 here. Here's the base, here's the acid. This is a 2-to-1 ratio. Okay, I can't do this problem without getting that mole ratio because I'm going to make a mole bridge from that. Okay, now what I want to do is add the sodium hydroxide to the oxalic acid. So keeps on going in, and eventually it drains down to say right there. And then I'm going to read that very specifically, and let's say it goes down to 26.29 milliliters. Get this out of my way. All right, so the difference between that is the amount of sodium hydroxide I actually used. We started up here, and it drained all the way to there. So I want to take 26.29, and I want to subtract 0.08. And that'll get me the actual amount that I used. So 26.21 milliliters actually drained out of the burette. Okay. Now I have no use for milliliters. Molarity is always calculated with liters. So I want to change this to 0.02621 liters of sodium hydroxide used. Okay. Now it's time for my actual calculation. I know exactly how much acid I started with. That's my first given. So I'm going to say that here's the amount of acid that I started with. I can convert from grams of acid to moles of acid. The lab tells me the molar mass of acid. So I know that 1 mole of acid has a mass of 126.08 grams of acid. Okay? Now I can cancel grams. Now I'm in moles of acid. I did all that work in the neutralization equation you see at the top of the screen in order to figure out the ratio between moles of acid and moles of base. I know that for every 1 mole of acid that reacts, 2 moles of the base, sodium hydroxide, will react. Now I can cancel moles of acid. Molarity of the base is what I'm trying to figure out. Molarity of the base is moles per liter. I have moles of base in the numerator. I want liters of base in the denominator. So if I calculate this out, it's going to be moles of base. Moles per liter is molarity. So rather than dividing by liters, or dividing by the volume, dividing by liters, I'm just going to multiply by the reciprocal. Because it's basically the same thing as saying if you're going to divide something by 2, that's the same as multiplying it by 1/2, 1/2 being the reciprocal of 2. So I'm going to put 1 over 0.02621 liters of the base. So now in the numerator, I have moles of base. In the denominator, I have liters of base. And if I calculate this out in my calculator, I will get 0.303 moles per liter. And that is us standardizing sodium hydroxide. We just figured out the molarity of sodium hydroxide. That was the entire point of Part A. We did Part A in order to figure out that concentration. So now we can use it in Part B to figure out the concentration of our other acid, which is vinegar. Notice that in this setup, we only had one unknown. We did know the mass of the acid. We did not know the molarity of the base. That's always going to be true in any titration you ever do. You're going to have something that you do know and something that you're trying to figure out. Okay? In Part A, we knew exactly how much acid we had in the flask, and we wanted to figure out the concentration of sodium hydroxide. So we did that using our Part A titration. Let's go to Part B now. All right, so now we're at Part B, and this is us using the concentration we just figured out in Part A in order to figure out the concentration of a different acid. This is acetic acid. Acetic acid is vinegar. Okay, and sodium hydroxide we of course know is NaOH. Now this time our unknown is the vinegar. We do not know the molarity of this vinegar. That is what we're trying to figure out. We do know the concentration of sodium hydroxide. We know that this is 0.303 molar, okay, or 0.303 moles per liter. So let's say we fill this burette with sodium hydroxide and we fill it to the 0.09 milliliter line. Okay. What we now need to realize is that we are going to be adding sodium hydroxide to the vinegar. All right, I want to see what that neutralization reaction actually looks like, because again, I'm going to need that mole bridge thing. So sodium hydroxide is NaOH. Acetic acid is HC2H3O2. All right, I'm going to underline my cation once, underline the anion twice. In this case, acetate is our anion here. It's a long one. So sodium will go with that. And the cation here, which is hydrogen, will recombine with the anion here, which is hydroxide, to form water. Now I just have to balance this, and I can see that it is actually already balanced. So I know that there is a 1 to 1, and these are 1s here over here too, a 1 to 1 molar ratio between the base, sodium hydroxide, and the acid, acetic acid. Okay, 1 to 1 molar ratio. All right, so let's actually add this sodium hydroxide, and it scrolls all the way down, it flows all the way down to that line. And that line, let's say it's 21.49 milliliters of sodium hydroxide. There is how much I actually used. That is going to be 21.49 minus 0.09. Dang it. That comes out to be 21.40 milliliters, but I want that in liters, so I go 0.02140 liters of sodium hydroxide. All right, so now I know how much base I used, and I know the molarity of the base. Two things I know about the base. The only unknown I have is the molarity of the vinegar. That's the entire point of part B. Okay, so now I'm ready to calculate. I want to start with what I am given. I know the molarity of sodium hydroxide. Okay, so in that second titration, in a part B type of titration, when we're just given like the molarity of one and we want the molarity of the other, we want to start with that molarity. So 0.303 moles of base per liter of base. All right, that's how I would write the molarity of the base if I were to put it in dimensional analysis, which I of course have to. I want to get from moles of base per liters of base to just moles of base. If I get it in just moles of base, not moles per liter, but just moles, I can go from moles of base to moles of acid. All right, I want to put myself in a situation where I can use the mole bridge. So I want to get rid of this liters of base in the denominator here. This is kind of the concept of like what's 5 over 2 times 2? The answer would be 5. Okay, if you multiply by the denominator, you get rid of the denominator. I want to multiply by liters of base in the numerator so I can get rid of these. I want to cancel this. All right, I can cancel it if I use the volume of the base. Here is my volume of the base up there. So 0.02140 liters of base. Now liters cancels. Now I'm just in moles of base. Now that I'm in moles of base, I can use the mole bridge. I figured out as a 1-to-1 ratio. So 1 mole of base reacts with 1 mole of acid. Moles of base gone, moles of base gone. Now I'm in moles of acid. How do I get molarity of acid? Molarity is moles per liter. Rather than dividing by liters, I'll just multiply by the reciprocal. So I don't have to do like multiple calculations. I can do it all in one dimensional analysis, perfect step here. So I want to multiply by the reciprocal, so I will divide by the amount of vinegar we use. And if you remember from lab, every time we filled the flask with vinegar, it was 10 milliliters. 10 milliliters equals 0.010 liters, 0.010 liters of the acid. Now I'm in moles of acid on top, liters of acid on the bottom, exactly what I need it to be. If I do that in my calculator, I will get 0.648 moles per liter. And that right there is the molarity of the vinegar, okay, the acetic acid. And that was the entire point of doing part A first. We needed to figure out the molarity of the sodium hydroxide in part A so we could use that information to figure out the molarity of the vinegar or the acetic acid in part B. Those are the two types of titration problems that you'll see on your quiz tomorrow. Keep in mind, it is a 10-question quiz. The first 5 are multiple choice, and they deal with procedural type questions from the lab. So a sample might be like, your flask turns a really bright pink. What did you do wrong? Or, your flask is not turning pink at all. What must have happened? What might you have done wrong? Okay, it's questions like that. And then the backside, you need to know how to read a burette. So you need to know how to do like the initial volume and then the final volume and subtract it to get your actual volume. You also need to know how to write your neutralization equations given certain substances, and you need to know how to do your calculations like we did at the bottom of part A and the bottom of part B. And that will do it. All right. See you guys tomorrow.